today I'm trying to convince you to, if you are, you, your friends, colleagues looking to get your data science PhD, I'm trying to convince you to not do it. And here's why. So there is no question that data science is a super high demand space. Plenty of charts that look like this. It is the kind of job that got ranked #1 job in America, 4 years straight. And I think for 2020, it got knocked down to #3, but still one of the highest demanding jobs. And it makes sense, right? Like that software is eating the world, and we are generating more and more data, and every company and teams trying to figure out what they should do with the data that they have, or what data they should be gathering, and therefore what kind of services and information that they can glean from data. So it makes sense in terms of it's a growth area. And again, I love working with the data scientists on my team, and continue to find them to be amazing. And it is such a fun, seeing the work that they do, it is incredible. But with that said, I want to share with you some personal experience, maybe draw some parallel to how technology are trending. So this is a long time ago. 20 years ago in my undergrad study, most of my programming were done in C. And I would say that like my first job also spent a lot of time coding in C and a little bit of C++. And I have spent countless hours dealing with memory management in C. Just having to, every little thing that you do, you have to think about how much memory you're allocating for a particular object in the array, where you're pointing your pointers. And so often, I ended up bumping into problems that I created or other people created when it comes to memory. You move with the pointer get pushed to the wrong place. You ended up having space allocated, and then it got free, and then there. A lot of years in my undergrad study, but since then, really haven't thought too much about memory. I've moved forward to using languages like Python, using Scala. Now, there's still things like Stack Overflow that you have to deal with, but a lot of times I did not have to think about allocating memory for every object that I am creating. And I can able to work in a much more abstract way in working with actually just building out the business logic and building product and features without thinking the low level details like memory allocation. The experience that I gained over that time really was not too transferable since then. A different example. So my first company was a big data machine learning play back in 2010. And it's fundamentally the back end of the system is a distributed computing system, stream processing a lot of data, a lot of real-time web traffic. So when we first started building it in 2010, we eventually building up to a 10-person engineering team, and we built our own stream processing system with Python. We grew as demand grew. We continued to refine the system and build, and we got pretty good. We were able to process 2 billion requests per month, servicing some of the biggest customers in media, including the likes of Forbes and weather.com and CNN of the world. But at that scale, we were also failing all the time on a weekly basis. The system was just, distributed system is just hard. It's just hard to build. And for a 10-person engineering team, that was just not our core expertise. And with that pain, kind of as we continue scaling the company and the product, with that framework. Eventually, 2000. It comes to switch over, but we did not need any more engineering resources. We were able to 6x our traffic, going up to 12 billion requests per month, was able to all of a sudden change the uptime promise to 99.9%. And that's actually when the time that we end up getting acquired, right? But that's certainly a big step in moving from knowing a lot of the little guts of distributed processing into leveraging a framework. If I were to build the same thing today, or an experienced backend engineer / AWS engineer were to build the same thing today using Lambda, S3, Kinesis, my estimate is probably going to take the person a month, one person. And you achieve almost infinite scale using the AWS ecosystem. And there's other, Google and other platform out there as well. And that's sort of, in a way, the personal perspective on seeing distributed computing going in 10 years, right? From us building everything to pretty much standard component across the board. Now, let's look at what about the AI machine learning space, right? And I picked a couple of examples here. There's many other tools, there's PyTorch, there, Google Cloud, many others, right? But just for illustrative purposes, take a look at TensorFlow and AWS SageMaker, right? TensorFlow was released 2015. Version 1 was released 2017. And then right after that, in the next few years, very quickly, some really exciting pieces came together, right? You have TensorFlow Lite for mobile, you have TensorFlow JS for JavaScript, and then getting TensorFlow Graphic, and then 2.0 came out in 2020. In sort of parallel path, you see that AWS SageMaker, which is their machine learning as a service solution, was launched in 2017. And then very quickly, a lot of these core machine learning should take a long patient model and able to experiment to like put versions on your models and your data. All those stuff that was really hard to do 2016, 2017, all of a sudden became the core offerings of the system. I can only see this path kind of move forward and this trajectory continue to move that way. So what does that mean then? So this is a pretty often quoted line for that data scientists spend 80% of their time cleaning data rather than creating insights. I mean, first of all, one other trend that I haven't quite talked about is this idea of digitalization, right? Companies, teams, from small company to Fortune 500s, for the past 10 years have been in these massive digital transformation effort. Going through from having PDFs and handwritten notes into consolidating 20 databases together. And of course, if you are a data scientist, sort of at the back end of this, sort of consume this information, the first thing you got to do is spend time just dealing with that, right? I'll venture to say that that has been changing, will continue to change, right? As a lot of these efforts come to an end, that things that get put into system that have that the machine learning system data makes sense in data cleaning less. Now, I just want to quickly pull out what does the PhD course look like. So this is what I've Stanford PhD course, both the core and the elective, so you don't have to take all of them. And I didn't mean for you to read all of them, but if you quickly scan it, pretty much you can have a good sense that like statistics, right? The fundamental theory of statistics is the core of what the PhD is about. And then so the question is that the set of tools that will enable many of you or many data scientists in the future to be successful? And I'll venture to say no. I would say that my ideal data scientist in the future, for the majority of the world, will go the same way as engineering, where having a full stack point of view will become much more valuable. Being able to go doing the underlying data, the analysis, the predictions, but also the data engineering, understanding of data sets and pushing forward. And then to some extent, knowing the underlying infrastructure, being able to define problems, be able to visualize data, get buy-ins, run experiments, doing it end to end and reducing the amount of cognitive load in terms of keep collaborating across a team of people doing individual steps. I think it's where you're going to add the most value to team and companies. Now, if you are working at Google's search quality team, or you are working on ranking TikTok's videos, absolutely, all the expert knowledge you get from a PhD will help you get that extra 0.1% of optimization you can get from this system, which have massive value because of scale. But again, I would say 99% of the of us out there, I think the biggest value come from a data scientist or a small team of data scientists being able to really work on real world problem, understanding the customer, doing the analytics, and then able to actually deploy things end to end. So hopefully this help you rethink, if you are considering this career, that I think there are many ways to be an amazing data scientist in 2020 and beyond. Thank you.